Hello students, welcome back. Let's go to tangency problems. Usually these are the toughest types of problems, but as a matter of fact, in this particular case, not that hard because many of the difficult parts are already done in part 3, derivatives. Let's see. First problem, find an equation of the tangent line y equals to x log of x minus x, and please recall you did this already. Same function as this. So what you can do is to recycle the answer for the previous part and then use that. Okay. Step 1, let me start from step 0. Anticipate your answer. Y equals to m x minus x 0 plus y 0. That's the equation you want. I did not specify which equation of the tangent line you should get in the end. Some people specify the slope-intercept equation. I usually don't. Anything will do. So it's easiest to keep it as the slope-point equation. Another way to do the same thing is like this. Oh, excuse me. I meant to get subtraction instead of like this. And this is the way Sullivan's algebra book described the slope-point equation of a line. So many people prefer this way. But then again, my preference is flip this y0 over to the other side and get that. If you use previous form, I don't mind, that's okay. In any case, here in this case, x0 is given as e to the negative 1 power. y0, we don't know. Oh, never mind. Okay, all right. Let's leave it at that. That's step 0. Oh, well, x is equal to negative 1 power, so let's just put it in here. Okay, all right. Let's write like this. So that's step 0. Let's go to step 1. Okay, x0 is e to the negative 1 power. So let's find out y0. And all you have to do now is to plug in directly here. So here I'm plugging in e to the negative 1 power, e to the negative 1 power in place of all those x's. All right, let's go ahead and do that. And then let's see, log and exponential cancel each other out. So we have e to the negative 1 power times minus 1 minus e to the negative 1 power. So everything is going to be simplified like this. If you prefer fraction form, you can write like this. I don't. But if you do prefer this way, you can write like this as well. I don't like the fraction form very much. I prefer power forms more. So let me just stop here. So that's your y0 value. Did I do all the computations correctly here? So that number goes over there. So far, this is our progress. x0, we got it. And y0, we just got it now. All right. Step 1. Actually, a lot of students just go directly over step 1, get it, and then plug those later, skipping this step 0. Okay, step 2. In homeworks, step 2 is usually the hardest. Not in this case. because we already did it. The derivative is log of x. So let's recycle the answer. Log of x. So, all right. And let's go to step 3. We need m. So this is a derivative. In order to get the slope, we have to evaluate the derivative at given x value. So this is log of x to the -1 power. And again, log and exponential just cancel each other out. We get -1. So that's the slope. So we have the slope m value, and then we have y-coordinate y0 value. Put everything together, you're going to get the final answer. Y equals to m x minus x0. So about the typo here. Minus plus actually, and then y0 already has negative sign here. And there goes the equation of the line, the slope point equation of the line. You can break it off and simplify, then you're going to get the slope intercept equation of the line, but I don't mind. Once you get an equation of the line, that's fine with me, because I said find an equation of the line, not the slope intercept form of the line. Let's see, is everything correct here? Okay, here, and in this answer key here, I broke off and then got the slope intercept equation too, but that's not really necessary. The last part here would have been required if you were doing MyMathLab, but no. The big reason I stopped using MyMathLab and went into WebAssign is because I didn't want to meddle with simplification in the end. Okay, all right, we got the first problem done. Let's go to the next problem, and this is an implicit differentiation problem. Oh, by the way, let's go to the first problem. Do I have visualization here? I think I did it. Yeah, here. Okay, that's a curve. That's this curve, x log of x minus x, and then this equation, this equation here, gives you this red line. As you can see, you have the tangency. Okay, find an equation of the tangent line of the given curve at the specified point. Now this is an implicit differentiation problem, so I cannot reuse anything we did over here. We'll have to calculate the derivative implicitly. Okay, here we go. Let's take the derivative of the left-hand side. Which derivative rule do I have to use? Clearly, it's the chain rule. Outside function becomes like this. And then inside, nothing changes inside. All right? Times, you have to multiply the derivative of the inside. Okay, let's go ahead. Let's take the derivative of the inside. What's the derivative of x cubed? What's the derivative of 2x? What's the derivative of 2y squared? And then let's go to the right-hand side. Actually, if this were in class, I would have waited a little bit until somebody stops me and points out my mistake. But this is online, so I can't really do that. So I did the role of that student, clever student, just now. I just made a mistake here. What's the mistake? Derivative, that's fine. Derivative, that's fine. This derivative, that's where the mistake is. The derivative by y is for y, yeah, but y is not the independent variable, so you have to multiply the derivative of the inside by chain rule. That's y prime. Or if you prefer to use dy dx, go ahead. I don't mind either way. In any case, the derivative pops out. Whenever you apply the derivative with respect to y, this y prime pops out. Alright, so much for the left-hand side, and let's go to the right-hand side. X times y squared, so this is going to be a product rule. The derivative of the first function times the second function plus first function times the derivative of the second function. What's the derivative of the second function in this case? 2y, but that's not complete. I need y prime. Whenever you apply the derivative rule with respect to y, we have to have this y prime. That is the essence of the implicit differentiation. Here, y squared is just copied. I didn't really do anything. The derivative was for x, so that's all there is. But here, this is just copying, and we use the derivative rule with respect to y. Y squared becomes 2y, so y prime pops out. That's the idea of implicit differentiation. Okay, now shall we break up and then solve for y prime? According to our textbook, you may have to do that if this were finding y prime or dy dx symbolically. But no, this is a tangent line problem, so you don't have to do that. Just plug in the numbers right away. If you plug in the numbers x equal to -1 and y equals to 1 directly without taking the derivative, then you're not going to get anything. You're going to get something like -1 equals to -1. That doesn't really help you very much. But after taking the derivative, you're going to get an equation of y prime, or let's do it this way. X is -1, y is 1, y prime, let's put it as m. And here, let's solve that equation. So that's -1 to the third power, and this is going to be -1, and this is going to be just 1. Oops. And then this is going to be -1, and that's 1, and y prime will be m, the slope. That's 1, that's -1, that's 1, and this is my m. As a matter of fact, I'm using computers, so I just copy and paste it and put everything in. But in reality, students will begin applying some simplification rather than just writing everything and then going into tedious steps. Most students will go to this directly. -1 to the third power, so -1. And then 2 times -1, so that's +2. And then 1 squared, so it doesn't really go. And then 2 minus 2, cross, cross. I cannot support cross here, so I'll just use gray to represent they're crossed out. So -1 to the second power, this whole thing is just dropping out, right? -1 to the second power is 1. So it is 3 times that. Excuse me, I'm using computers, so I can always copy and paste. Like this. And then go ahead with this one. -1 squared, that's just 1. And 4 times 1, I don't need that. And then 3 minus 2 is 1, right? That's what we get. And then to the right hand side, 1 squared, that's gone. And then times 1, I don't need it. And then this is going to be minus 2m. So 1 minus 2m equals to distribute 3. So that's going to be 3, and this is 12. All of a sudden I have something really manageable. So flip this 12m to the other side and the 1 to the other side too. Then I'm going to get 2 equals to 10m. Let's see, did I do this correctly? Yes, I did. I'm supposed to get 1/5 and I got it. Please check my computation here. So I got the slope. The point is already there. So therefore, y equals to 1/5 x minus minus plus. That's the equation of the tangent line. The slope point equation of the tangent line. Okay, this was actual minus of -1, but I can easily put those into +1 like this. If you break up and simplify, you're going to get slope-intercept equation. Okay, I don't need all these anymore. Let's go to the answer key here. The same computation we did. Okay, and then finally, here's a visualization. We have this heart-shaped curve, and then we have this slanted line, which looks like has about a slope of 1/5. Okay, do I have enough time for another problem now? I guess not. Let's stop here.